Hey guys, this is Spiral V for Spiral 11. We're going to start off with quadratic models and exponent rules. First up, we've got another free fall type problem. I'd like to remind you again that you're given this equation, which basically we just have to plug these values in for. So if we're looking at this, we've got a baseball pitching machine that's being launched upward at 75 miles per hour off the ground. Okay. This is not actually a greatly worded question because 75 miles per hour needs to be converted into feet per second. So I'm going to instead say this should be in feet per second to simplify our work here. So 75 feet per second off the ground. And if I take a look at that, that means that my initial velocity, we say v sub 0 is 75. Off the ground means that my initial height, h sub 0, is going to be 0. So my equation would become h of t, in other words, the height based on time, not h times t, but h of t, is negative 16 t squared plus 75 t plus 0. Okay. After how long will the ball hit the ground? Well, we know the ball starts on the ground, that's 0, so it hits the ground when it comes back to 0. So 0 equals negative 16t squared plus 75t. Okay? I can do some factoring, and I get t multiplied by negative 16t plus 75. All right, that means that t equals 0. And for my other part, I get 16t is equal to 75. In other words, t is going to be 75 over 16 seconds when it hits the ground again. And just to remind us, the shape of the path is going to look like this. Here's 0. Here's 75 over 16. And the maximum is always going to occur halfway through, in other words, at the vertex. So if I'm looking for the maximum height, the time that's going to happen is going to be 75 over 16 divided by 2, or otherwise known as 75 over 32. Okay, to find the height, I've got to find the time plugged into my equation. So h of 75 over 32. And again, this is not multiply. This means we're plugging in that number. So you've got negative 16, 75 over 32 squared, and then plus 75 for the v sub 0 and 75 over 32. I don't have a calculator on me at the moment, so whatever that comes out to is going to be our answer. For the sake of time, I'm not going to do that by hand. Exponent rules. We got to start with our number 1 here. X squared over x to the 7th. We know we're going to subtract that. So that'd be x to the negative 5. In other words, 1 over x to the positive 5. You might also notice you could have subtracted up 7 minus 2 and kept the 5x on the bottom. Second one, x squared over x to the 1st. Y cubed over y squared. 2 minus 1 is 1, so x to the 1st. 3 minus 2 is 1. xy is our answer. Third one, we've got 6x squared y to the negative 3, all to the 2nd power. I'm going to deal with that first. 6 squared is 36. X squared squared, 2 times 2 is 4. Y to the negative 3 to the negative 2 is going to be negative 6. And then we've got 3x y cubed to the negative 1. So I'm going to write that as the reciprocal of itself. So 1 over 3x y cubed. Okay. I know this first guy I could write as over 1. So I could really treat this as 36 x to the 4th y to the negative 6 over 3 x y to the 3. 36 divided by 3 is 12. x to the 4 divided by x to the 1 is x to the 3. Y to the negative 6 divided by y to the 3 is going to be y to the negative 9. And finally, let's get rid of that negative exponent. We end up with this as 12x to the 3 over y to the 9. All right, last, we've got 8 times 2 is 16. X squared times x to the 5th is going to be x to the 7. I'm adding those exponents. Y to the 5, y to the 3. It's going to be y to the negative 2. To get rid of that negative exponent, we're going to write this as 16x to the 7 over y squared. Next up, we got the polynomial basic section. I'm going to basically be either combining like terms or distributing on the left. On the right, I'm going to be sketching some polynomials. Okay, first up, 5x squared minus negative 8x squared is going to be 5x squared plus 8x squared, or 13x squared. Negative 7x minus negative 2x is going to be minus 5x. And 8 minus 13 is going to be minus 5. Second one, 13x to the 5th doesn't have anything matching, so I'm going to keep that by itself. Negative 3x to the 3rd minus 4x to the 3rd is negative 7x to the 3rd, plus 2x minus negative 7x is plus 9x. And minus 1 minus negative 3 would be plus 2. Again, those are just combining like terms and being careful with your signs. Then we got some distribution going on here. 2x times 3x squared is 6x cubed. 2x times minus 2x is minus 4x squared. 2x times 4 is plus 8x. 1 times 3x squared is 3x squared. 1 times minus 2x is minus 2x. And 1 times 4 is plus 4. All right, 6x cubed, nothing in common. Bring it down. Minus 4x squared plus 3x squared is going to be minus 1x squared. Plus 8x minus 2x is plus 6x. And then I've got a plus 4. That's our final answer. Next one, same thing. 3x squared times 4x is going to be 12x cubed. 3x squared times minus 1 is minus 3x squared. 2x times 4x is plus 8x squared. 2x times negative 1 is minus 2x. Minus 2 times 4x is minus 8x. And minus 2 times minus 1 is plus 2. Bring the 12x cubed down, it's by itself. Then we've got negative 3 plus 8 is 5x squared. Minus 2 minus 8 is minus 10x. And plus 2. For number 10, we got to sketch a graph of this polynomial. I'm going to zoom out a little bit. And first thing I'm going to do is take a look at my zeros. They all have a multiplicity of 1, so these are all going to be straight-on pass-throughs. This is positive out front. I'm going to predict my graph looks like a W with 4 times that it crosses. Let's find some of these points. My x-intercepts are going to be 5, negative 2, negative 1, and positive 7. My y-intercept, that's when I plug in 0 for x, I get negative 5 times 2 times 1 times negative 7. That looks like it's going to be at positive 70. All right, so I'll put my y-intercept in, make sure I mark how high that is. Then I'm going to go, well, there's negative 1, there's negative 2, and then I've got to go to 5, 1, 2, 3, 4, 5, and 6, 7. All right. I've got to go through my y-intercept and make a nice smooth curve to each of the points on the other side, and then find a way to get back up. Those are the only places I can cross the x-axis. And what do you know? That looks sort of like what I predicted. As the last piece, I'll talk about the end behavior. As x approaches infinity, y is approaching infinity here. In other words, we're rising to the right. And as x approaches negative infinity, y approaches positive infinity. In other words, we're also rising to the left. last one of these. A couple things going on. First off, I've got 1 of the multiplicity 2. That's going to be a bounce at this location. I've got 1, 2, 3, 4 things, so I should have some kind of a W. The negative suggests that my W will be going down. And let's see what we get out of our graph. All right, x-intercepts. -5, -7, and 7. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. I'm just going to write bounce under my positive 7, 1, just so I remember when I go about and graph this. Now I need the y-intercept, so that's going to be negative, plug in 0 for x, 5, 7, -7. When I multiply these together, -5 times 7 is -35. That times 7 is going to be positive 210, 245. And actually, this should be -7 squared. So that's going to be positive 245 times -7. It should be something like -1778. And don't worry, I didn't do that magically in my head. I got a calculator for that one. So -1778. From there, I'm going to draw in my nice smooth curve to my next points. The bounce here means I'm going to hit that point and bounce off to go this way. No bounce means I'm going to slide through, go to my next x-intercept. I can't go anywhere else as far as x-intercepts. I predicted a W upside down. I got that. The end behavior is x approaches infinity, y approaches -infinity, or it falls to the right. And as x approaches -infinity, y approaches -infinity also. In other words, this falls to the left. Next up, we got some polynomial division and some factoring stuff. This is our new section. I'm going to talk first about the division stuff. First thing we got is x squared minus 2 dividing into x to the 4th plus 2x squared minus 8. First thing I notice is that this is an x squared. I cannot use synthetic division for this. I have to use long division. And I'm going to rewrite this as x squared minus 2 dividing into x to the 4th plus 0x cubed plus 2x squared plus 0x minus 8. Okay, that's just to make sure that I have placeholders there for x cubed and x. In this problem, I'm not going to end up using those, but I want to make sure that they're just in case I need them. Okay, I'm looking for what multiplies to get from x squared to x to the 4th. That's going to be x squared. When I multiply that down, I've got x to the 4th, and then minus 2x squared, which doesn't actually go under here, so I'm going to put a block there. Minus 2x squared. Okay. I'm going to subtract that. X to the 4th minus x to the 4th is 0. That doesn't matter because that's 0 anyway. And then we've got 2x squared minus negative 2x squared is 4x squared. Okay, to get from x squared to 4x squared by multiplication, I've got to multiply by 4. Before I do that, I want to break down these guys. 0x minus 8. Alright, so this should be a plus 4. Multiplying that down, we get 4x squared and then minus 8. So that's 0x minus 8 goes under the 8. Subtract, I get 0 and 0. Which means I don't have a remainder. The second question here asks if x squared minus 2 is a factor of x to the 4th plus 2x squared minus 8. And I'd like to think about this. Okay, so when we divided this, we got no remainder. Since we got no remainder, yes, since there was no remainder. Remember that if something is a factor, it just means that it's divisible. All right. Next one, we got x minus 2 being divided into a polynomial. Since this is an x minus 2, I can use synthetic division, so for this one I will. And I'm going to set this up. I use the opposite of minus 2, 2 out front. I write my coefficients, there are none missing, cubed, squared, x, and negative 8. First thing I do is I bring down my first term, and then I multiply 2 times 1 is 2. I add, negative 2 plus 2 is 0. I multiply, 2 times 0 is 0. And then I add, 4 plus 0 is 4. And then I multiply, 2 times 4 is 8. And then I add, negative 8 plus 8 is 0. I'd like to remind us that that last number is always the remainder. So we have remainder 0. We've got 4. This should be 0x, so I'm going to just skip that. Then we're going to have 1x squared. So when we divide this, we got 1x squared plus 4. So that means that x minus 2 is a factor. And more importantly for this question, if x minus 2 is a factor, we need to know that x equals 2 is a 0. And so the answer to that last thing is yes. Since x minus 2 is a factor, x equals 2 is a 0. Alternatively, you might remember that we talked about the remainder theorem, which told us that if we plugged in 2, we get the same value as if we divided by x minus 2. So we got 0 as the remainder. If I plugged in 2, I'd get 0 as an answer, which is why that's a 0. Last stuff, we've got some factoring. First thing I always want to do if I see factoring of a cubic, or if I see a cubic in general that I know I need to factor, I'm going to try factoring by grouping. This is by far the easiest method to factor this, and if I can do this, I don't have to do any other crazy methods that we haven't really gotten to yet. I'm going to get x squared pulling out of those two, and I've got an x plus 2. And take a minus 9 out of my second 2, and I'm left with x plus 2. This is going to factor into x squared minus 9 and x plus 2. X squared minus 9 is factorable. If I'm trying to factor this completely, it's important that I go a step further. X squared minus 9 is a difference of 2 squareds. So I'm going to write difference of squares. And just to remind you, if I've got x squared minus a squared, that's going to factor into x plus a, x minus a. So in this case, I've got x squared minus 9. 9 is 3 squared. I could write that as x plus 3, x minus 3, and then I've got an x plus 2 from up there. This is my fully factored form of that expression. This last guy, if I take a look here, I've got x to the 4th and an x squared and then nothing. This is going to be a quadratic-like. And it's quadratic-like because that first power is twice as big as the second power. We've got just a number at the end. So I'm going to do my a times c, so minus 64 x to the 4th. And I'm going to add up to 12. Two things that multiply to negative 64. X to the 4th and add up to 12x squared. That's going to end up being positive 16x squared and negative 4x squared. Okay, so we've got x to the 4th plus 16x squared minus 4x squared minus 64. When I go to factor this, I get x squared out of the first two. I'm left with x squared plus 16. I can take a minus 4 out of the next two. And I'm left with x squared plus 16. That's going to turn to x squared minus 4 and x squared plus 16. This is the difference of 2 squares. That's going to be x plus 2, x minus 2. We don't have a rule for sum of two squares, so that's going to stay as x squared plus 16, and at this point we are done. That is fully factored.